Sometimes we need to resolve a vector into components with relation to either another vector or other directions. So we have a little trolley here, and we've got a handle, and the handle's at 45 degrees to the ground, and we're pulling the trolley with a force of 10 newtons. It's possible to work out the force that is parallel to the ground. So if we write vector P with a little parallel symbol there is the component of P, in other words the part of P that is parallel to the ground. Now where on the diagram would we put that? So we want the part of this force that is parallel to the ground. It would simply be straight out to there. So that's P parallel. The other component would be perpendicular to the ground, would be the, and we will call that P perpendicular with a little perpendicular symbol there. So that's the component of P, the part of P that is perpendicular to the ground. So that will be that one there. So that's vector P parallel, that's vector P perpendicular. So from the diagram, we can see, because that is perpendicular, we've got a right angle triangle, and it is possible to work out the magnitude of these two. So P parallel, we know that the cos of 45 degrees is adjacent over hypotenuse, so that will be the magnitude of P parallel over 10, 10 being the hypotenuse there. And this is where the special triangles came in. We know cos of 45 degrees. As soon as you see that, we should be able to write down our special triangle that's got 45 degrees in it, and we know that's 1, 1 and root 2. So we know that the cos of 45 is 1 on root 2, so 1 on root 2 equals the part of force P that is parallel to the ground, all over 10. And by multiplying both sides by 10, we've got 10 over root 2 is equal to the value of P parallel. And 10 over root 2 is around about 7.071. So this force acting up the handle, if we wanted to know the size of the force, and that's all it is, the size of the force that would be acting parallel to the ground, it would be 7.071 newtons. Likewise, we can work out P perpendicular. So P perpendicular, we've got the sine of 45 degrees is the magnitude of P perpendicular. Sine is opposite over hypotenuse, and that's P perpendicular all over 10. And once again, sine 45 from our special triangle, sine of 45 is opposite over hypotenuse, so that's 1 on root 2. So we've got 1 on root 2. Multiply both sides by 10. So we've got the component of P that is actually acting perpendicular to the ground. That's what P perpendicular is, the component of P that's perpendicular to the ground, is equal to 10 over root 2 on your calculator, 7.071. So because this is 45, you know, that's 45, so these two magnitudes have to be the same anyway. And they're both equal to 7.071 newtons. So if you've got a parallel, the amount of P that is acting parallel to the ground is 7.071, and the amount of this force here that is acting perpendicular to the ground is also 7.071. So sometimes we need to resolve a vector into its components with relation to either direction or another vector.